Okay, this one is MISLECompetency2, matrix inverse system of linear equations. Find inverses of 3 by 3 matrices using row reduction. So here it's just a plug and chug process. You take this A and you take the extended echelon matrix, which is you take A and I and then reduce. Okay? So in this case that means 1, 0, 0, 1, 0, 0. And then here you have 4, 6, 0, 0, 1, 0. And here we have 3, 9, minus 3, 0, 0, 1. Now in this case, it is pretty not very difficult to reduce this. The first row is already there. It's basically the second and third row that you have to take care of. Second row, I just take minus 4r1 plus r2. And then the third row is going to be minus 3r1 plus r3. And because I'm eliminating the entries in the first column in these two rows, I can do these two operations at the same time. So the first row doesn't change. Second row, minus 4 plus 1 plus 4 is 0. 0 plus 0 is 6. 0 plus 0 is 0. Minus 4 plus 0 is minus 4. 0 plus 1 is 1. 0. Okay. Last row. Minus 3 plus 3 is 0. 0 plus 9 is 9. 0 plus minus 3 is minus 3. Minus 3 plus 0 is minus 3. 0 plus 0 is 0. 0 plus 1 is 1. Okay. Now we just got a couple more entries to take care of. Let's go ahead and make this one a 1, because we're certainly going to need to do that. Pull down. Oh, it's not letting me pull down. Here we go. Okay. And change this to here. Okay. And then we're going to take R2 over 6, or 1/6 R2. That gives me 1, 0, 0, 1, 0, 0 for the first row, 0, 1, 0, minus 4 over 6 is the same as minus 2 over 3, 1 over 6, and 0. Last row, let's just leave that for now. 0, 9, minus 3, minus 3, 0, 1. Okay. So we're going to have to get rid of this 9. So I'm going to take minus 9 times row 2 plus row 3. And that's going to give me 1, 0, 0, 1, 0, 0. First row doesn't change. 0, 1, 0, minus 2/3, 1/6, and 0. That row doesn't change. Then here we have 0, minus 9 plus 9, 0. Minus 9 plus 0 plus minus 3, minus 3. Minus 9 times minus 2/3. Well, one of the 3's cancel. That gives me 6. Minus 3 gives me 3. Minus 9, 6 is the same as minus 3/2 plus 0, minus 3/2. And 0 plus 1 is 1. Okay. Not quite done. We need to take care of this minus 3. So my last one is going to be minus 1/3 R3. And that's going to give me, finally, 1, 0, 0, 1, 0, 0. 0, 1, 0, minus 2/3, 1/6, 0. Sorry about the sloppy writing. And this is 0, 0. Minus 3 becomes a 1 when I multiply by minus 1/3. Minus 1/3 times 3 is minus 1. Minus 1/3 times minus 3/2 is 1/2. Minus 1/3 times 1 is minus 1/3. Okay? All right, so my final result is 1. Notice something here. I've got 1, 0, 0. And then I've got 1 over 6 minus 1 over 3 on the diagonal. It's still lower triangular, like the original matrix was lower triangular. Here I have minus 2 over 3. Here I have minus 1. And I believe this is a 1/2. All right, now this is what I would call B. You should check that AB equals BA equals the identity. Sorry, not B equals A, equals BA equals the identity. So far, the proof of extended echelon shows that AB is equal to I. Later on, we'll see that AB equals I implies BA equals I if both A and B are square. If they're not square, that's not necessarily true. But in this case, you do have a square matrix. And, of course, you can't have an inverse matrix if you don't have a square matrix. So you can check this result. It's not too many matrix multiplications. And that's how you find the inverse.